بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Math grade 8. We are in model 8, lesson 3, rotations. Today we want to learn rotations. So in this lesson we want to use the coordinate notation to find the coordinates of a figure that has been rotated about the origin, as well as describe the angle of rotation using the given graph and coordinates of the figures. The first idea in this lesson, rotation about a vertex. Rotation about a vertex. What's the meaning of a rotation? A rotation is a transformation in which a figure is rotated, or turned about a fixed point. What the meaning of the center of rotation is the fixed point. A rotation does not change the size or shape of the figure. So the pre-image and image are congruent. Rotation can be described in degrees and direction. So the first is 90-degree clockwise, and 270-degree counterclockwise. So as you see, this is the clock. For example, so we have two directions, clockwise from left to the right, and counterclockwise means from right to the left. From right to the left are two examples of possible descriptions of rotation. So the animation shows two different rotation of triangle ABC about vertex A. As you see, here we have the pre-image. And here A, this is the center of the rotation. And when you rotate this triangle clockwise, and the degree will be 90, you will get here the image. Now, as you see, this is line AB, and this is line A prime, B prime. The angle between them will be 90 degrees. This is the angle of rotation. This is the angle of rotation. So in 90 clockwise rotation about vertex A, each point and line segment are rotated that same number of degrees clockwise about the same vertex A. And the second example here, in a 180-degree counterclockwise rotation about vertex A, each point and line segment are rotated that same number of degrees counterclockwise about the same vertex A. As you see here, we have the pre-image. This is the triangle ABC. And the center of the rotation will be A. And we want to make rotate from right to left, means counterclockwise. And the angle of the rotation will be 180. So this is the center. This is the line AB. And the angle will be, with the image, will be 180. means the same straight line, A prime, B prime. And this is the image. This is the image. So this is the meaning of the rotation. In this example here, the animation also shows the following rotation of triangle ABC in a 270-degree clockwise rotation about vertex A. Each point and line segment are rotated that same number of degrees clockwise about the same vertex A. So as you see, this is the three image ABC, and this is the center of the rotation. And we want to do rotation clockwise, means from left to the right, clockwise. So this is AB. Rotate AB using the angle 270 degree. We will get A prime, B prime. And the same idea for the all sides. You will get here the image A prime, B prime, C prime. The example here, rotate figures about a vertex triangle LMN with the vertices L5, 4 and M5, 7 and N8, 7 represents a disk in a Jackson's pattern. He wants to rotate the disk counterclockwise using this angle 180 about the vertex L. Graph the figure and its image, write the coordinates of triangle L prime, M prime, M prime. So the first step, graph the figure and its image. So this is the figure, LMN. Step 1, graph the original triangle. Then graph the rotated image. The center, as you see, will be L. You can't choose any side, for example, ML. The rotation counterclockwise means from right to the left. Then make angle 180, you will get L prime, M prime in the same straight line with ML, as you see. Then you can do the same idea with L prime M. You will get L prime M prime. Then you can match between them, or you can do the same idea with MN. You will get here parallel lines. So you will get here the image L prime, triangle L prime, M prime, M prime. So use a protractor to measure an angle of 180 with M as 1 point on the ray and L as the vertex. Mark off a point the same length as ML. Label this point M prime as shown. Then the third step, repeat step 2 for point M. Since L is the point at which triangle LMN is rotated, L prime will be in the same position as L. The second part, part B, write the coordinates of the image. Use the graph to write the coordinate of the vertices of the image. So as you see here, L prime, this is L prime, will be here 5 in the X, and will be here 4 in the Y. M prime will be 5, 1. M prime will be 5, 1. And N prime will be 2, 1. Rectangle ABCD with vertices A, B, C, and D represents the bed in the jigsaw room. Graph the figure and its image. After a clockwise rotation of 90 degrees above vertex C, then write the coordinates of the rectangle A prime, A prime, B prime, C prime, and D prime. So the first part A, graph the figure and its image after a clockwise rotation of 90 degrees above the vertex C. So as you see here, we have A, B, C, D. This is the pre-image. We have C here, the center of the rotation. And we have clockwise, means from left to the right. We want to rotate this figure about the center C using the angle 90 degrees clockwise from left to the right. So as you see, this side, take this side BC, use the protractor, then determine the angle 90 degrees. You will get C prime, B prime. Use the same idea for BA and AD and DC. You will get B prime, A prime, A prime, D prime, D prime, C prime. And you will get C prime, B prime, A prime, D prime. This is the image. This is the image. Then you can write the coordinates of the rectangle A prime, B prime, C prime, D prime. So as you see here, A prime will be 1 in the X and 6 in the Y. And B prime, as you see here, will be -2 and 6. And we have C prime will be -2, 1. And D prime will be 1, 1. Rotations about the origin. The coordinates of an image rotated clockwise about the origin can be determined using a coordinate rotation when a figure is rotated about the origin. The center of the rotation is 0, 0. So each point of the original figure and its image are the same distance from the origin. A rotation, pre-image, and image are congruent. Okay, now as you see, we have 90-degree clockwise rotation about the origin. The x coordinate of the image is the same as the y coordinate of the pre-image. The y coordinate of the image is the opposite of the x coordinate of the image. So as we see here, if you have this point xy, after the rotation clockwise 90 degrees, you will get y -x. xy will be what? Will be y -x. If you have 90 degrees. And if you have 180 clockwise rotation about the origin, the x and y coordinate of the image are opposites of the x and y coordinates of the free image. And when you have 180 clockwise, as you see, xy will be what? Will be negative x, negative y. Will be negative x, negative y. And when you have 270 clockwise rotation about the origin, the x coordinate of the image is the opposite of the y coordinate of the free image. So the y coordinate of the image is the same as the x coordinate of the free image. And when you have this angle 270, xy will be negative y, x will be negative y, x. Now, as you see, we have three important cases. When you have the center will be in the origin. The first case, if you have the angle 90 degree clockwise. So the rotation xy will be y negative x. Xy will be y negative x. And suppose that you have 1, 2. The rotation in this case will be 2 minus 1. This is the meaning of xy will be y minus x. If you have 1, 2, means keep the same y, 2, and take the opposite of x. Take the opposite of x will be 2, negative 1. And the second case, when you have xy, the rotation, when you have this angle, the rotation will be negative x, negative y. Suppose you have 2, 3, the rotation will be negative 2, negative 3. And the third case, if you have this angle 270, xy will be negative yx, xy will be negative yx. So suppose you have 1, 3, the rotation will be, in this case, minus 3, 1. Switch between them, then take the opposite of y and keep the same x. Example. Rotate using coordinates. Triangle DEF has a vertices D, E, F. The triangle is rotated 90 degree clockwise above the origin. So write the coordinate rotation for a clockwise rotation of 90 about the origin. Then write the coordinates of triangle D prime, E prime, F prime. Part A, write the coordinate notation for clockwise rotation of 90 degree above the origin. We're rotating a point 90 degree above the origin. The x coordinate of the image is the same as the y coordinate of the image. And the y coordinate of the image is the opposite of the x coordinate of the image. So the coordinate notation is xy will be y negative x. Because here we have 90 degree. When you have 90 degree, means we have this rule. The rotation of xy, keep the same y, but put it in the x place, and take the negative x and put it in the y place. So y negative x. So as you see here, write the coordinates of triangle D prime, E prime, and F prime. And we have D negative 4, 4. The rule said take the y, put it in the x, 4, 4. Then take the opposite of x, put it in the y. The opposite of negative 4 will be 4. So we will get 4, 4. And here, E negative 1, 2. Take the y, put it in the x place, and take the opposite x will be negative 1 will be 1, and put it in the y place. Then here if minus 3, 1, take the y, put it in the x place, then take the opposite of x will be 3, put it in the y place. The second example here, quadrilateral M and BQ has a coordinates M and B and Q. The quadrilateral is rotated 180 clockwise about the origin. Write the coordinate rotation for clockwise rotation of 180 about the origin. Then write the coordinate of the quadrilateral M prime, M prime, P prime, Q prime. So part A, write the coordinate rotation for a clockwise rotation of 180 about the origin. As you see, when you have 180 clockwise about the origin, this is the rule. XY, the rotation will be negative X, negative Y. Take the opposite of X and the opposite of Y. So M2, 5. Take the opposite of 2 and the opposite of 5 will be negative 2, negative 5. N6, 4 will be negative 6, negative 4. B6, 1 will be negative 6, negative 1. Q2, 1 means negative 2, negative 1. Describe rotation. Use coordinate rotation to describe the rotation, then determine the angle of the rotation. Assume the rotation is clockwise about the origin. As you see, this is the image here, this is the pre-image here, and this is the image here. So, part A, the first step, use coordinate rotation to describe the rotation. Compare the coordinates of the pre-image and the image. And from the graph, we can write the coordinate of A, B, C. This is the pre-image. As you see here, A will be negative 6, negative 2. This is here A, negative 6. And this is here negative 2. B will be negative 5, 1. This is B. This is here negative 5. And here 1. And C, negative 2, negative 3. This is C, negative 2, negative 3. And the same idea, we can use it to find C prime, A prime, B prime. So as you see, A prime will be 6, 2, and B prime will be 5, negative 1, and C prime will be 2, 3. Now we want to describe this rotation. If you compare A with A prime, as you see the X here negative 6, the X here will be the opposite, will be 6. And here the Y negative 2, the Y will be 2. So means here we have XY, the rotation will be negative X, negative Y. Means the angle will be 180 and the center will be 0, 0, the origin. And here we have clockwise. So the coordinates of the pre-image are the opposite of the coordinates of the image. So the coordinate rotation is xy will be negative x, negative y, then determine the angle of the rotation. In this case, the angle will be the coordinate rotation for 180-degree clockwise. Rotation about the origin is x, y will be negative x, negative y. So the angle of rotation will be 180. The second example here, use coordinate rotation to describe the rotation. Then determine the angle of the rotation. Assume the rotation is clockwise about the origin. Right. We can do here the same idea. What is the coordinate of A? As you see, this is A here. 1, 2, 3, 4, 5. And here in the Y will be 2. So A will be 5. What is A prime? This is A prime here. As you see, 2 in the X and negative 5 in the Y. So 2, negative 5. And when you compare between A and A prime, you will get here. The X here in A, take the opposite X and put it in the Y. The opposite X minus, the opposite 5 minus 5 and put it in the Y. Then take the Y, put it in the X. So in this case, we have this rule. Each xy will be what? Will be y negative x. Will be y negative x. So this is the rule of the angle 90 degree. So the angle will be what? Will be 90 degree. If you take the negative x and put it in the y, and you put y in the x place, so means the rotation, the angle of the rotation here will be 90 degree clockwise about the origin. The last example in this lesson, before arranging the furniture in his office, Tyron made a diagram of the current arrangement. He drew a rectangle ABCD to represent phi given with the vertices A, B, C, and D. He moved the phi given twice. First, translating is 4 units right and 3 units down. Then rotating it 180 clockwise about the origin. What are the coordinates of the vertices of the final image after this transformation are applicable? And the first step, as you see, we do translating. The rule of the translating, if you have xy, to translate will be, so here you have A and we have B. 4 units right means 4 or plus 4. 3 units down means minus 3. Down means minus. So the rule will be x plus A means x plus 4. And y plus B means y minus 3.
So the translation or the translation of A17, you will get here A prime 1, this is A1, 1 plus 4 will be 5, and Y7, 7 minus 3 will be 4. Then the second point be 3, 7. The translation will be B prime X3, 3 plus 4 will be 7. And Y7, 7 minus 3 will be 4. Then the same idea for C equal 3, 4. So the translation will be C prime X3, 3 plus 4 will be 7. And Y4, 4 minus 3 will be 1. And the last point, D, 1, 4, the translation will be B prime X1, 1 plus 4 will be 5. And this is Y4, 4 minus 3 will be. Then, after the translation, we do rotation. And the angle of this rotation will be 180. And as you remember, the rule of the rotation, if you have a xy, if the angle 180 clockwise about the center 0, 0 or about the origin, you can take the opposite x minus x. Then take the opposite y minus. Now, we want to use this rule to get the rotation. And if you go back to the A prime and do this rule, take the opposite x and the opposite y will be -5, -4. This is A2 prime. And the same idea for the V prime. You have 7, 4. Take the opposite of x and the opposite of y will be -7, -4, and this is P2 prime. And the same idea for the C prime 7, 1 will be -7, -1, and the same idea for the D prime 5, 1 will be -5, -1. So this is our ideas for this lesson. Who has any question about these ideas? No questions? Are all ideas clear for all? Okay. So this is our lesson for today. I will send to you the homework, inshallah, on the Teams. See you tomorrow, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.